There's two different ways we're going to learn how to solve a system by doing it algebraically with math instead of just graphing. And one of those ways is by substitution. So when I'm using substitution, substituting means we're replacing. So we're going to replace a variable, and it could be either one, with something, with what it is equal to. So our first example is pretty straightforward. Down here it says that the y value is 7. So I'm going to go up here and I'm going to replace that y with what y is equal to. Y is equal to 7. So then that new equation becomes, instead of y, 7 equals 8x minus 9. And then once I have that substituted in, now that I only have one variable left in my equation, I can solve the equation like normal. So the opposite of minus 9 is plus 9. And that's going to give me 16 is equal to 8x. And I can divide both sides by that 8. And I get that x equals 2. And our goal is to try to find out what x and y are. So I already knew what x was. X was 7. And now I know that, y was 7. Now I know that x is 2. So then my final answer is the point 2, 7. And if we remember from the last lesson where we solved by graphing, the answer is where these 2 points cross. So if we were to picture these two graphs, they would cross at the point 2, 7. Or that means that algebraically I can plug in the point 2, 7 and they're going to work for both of the equations. Number 2 set up the same way. So we already know that x is 8. So I'm going to go up here, I'm going to plug in and replace the x with the 8 because they're the same thing, they're equal. So then I'm going to have, instead of x, 8 plus 3y equals negative 4. And then I'm going to solve like normal. So minus 8 from both sides to make that 0. It's going to be negative 12. And then divide both sides by the 3. Y is going to equal negative 4. And again, we already knew what the x was. X was 8, and now I know that y is negative 4. So my answer is going to be the point 8, negative 4. Again, that would be where those two lines would cross. And it's also the solution that's going to work in both equations. When we're looking at number 3, we can see that we don't have a variable already all by itself like we did in number 1 and 2. Number 1, we knew that y was 7. Number 2, we knew that x was 8. But we do have this bottom equation is really close to being solved. So we can go ahead and solve that one. We divide by 3 on both sides. Then we can see that x is going to equal negative 5. So then what I can do, and I can take this fact that I know that x is the same thing as negative 5, and I can go into this other equation, and I can replace that x with a negative 5. So then that's going to look like this. Instead of 6 times x, it's going to be 6 times negative 5. Everything else stays the same. So plus 4y is equal to 6. And then we just think all the way back to chapter 1, and we're solving equations. So this is going to be negative 30 plus 4y is equal to 6. Then again, our goal is to get that y by itself. So I need to get rid of this minus 30 by doing the opposite, so plus 30. Our goal is to make this 0, so it cancels out from this side. And then we're going to have 4y is equal to 36. Divide both sides by 4. So now y equals 9. So then we knew that x is negative 5. Now we know that the y is 9. So then our final answer for this one is going to be the ordered pair negative 5, 9. Number 4. So we have, both equations have an x and a y. So this one's going to be a little bit longer problem to solve. But if I look, this y down here is almost by itself. So if I can get rid of this 2x, which I can do that by doing minus 2x, and that's going to make that x go away. So now I have y by itself. Y is equal to 20 minus 2x. Or if you want to say negative 2x plus 20. But what you can't do is say 18x because those are not like terms. So it looks a little bit different than the last three we did, but we do know that now y equals, which means y is the same thing as 20 minus 2x. So we're going to go up to the other equation, and where I see the y, I'm going to replace the y with this whole thing, 20 minus 2x. So we're going to start with the 6x minus 5, but instead of 5 times y, we're replacing that y with what is y equal to. Y is equal to all of this, 20 minus 2x. And then I have to put that in parentheses so that I make sure I multiply negative 5 times everything, which means I'm going to have to do distributive property to make sure I multiply negative 5 times everything. And then we still have, let's finish off that equation, is equal to 12. So I've mostly just copied this top equation, but I replaced the y with what y is equal to. This whole thing, 20 minus 2x. And now we're going to solve the equation. I'm going to do distributive property first. Negative 5 times 20 is negative 100. Negative 5 times negative 2x is positive 10x. And we still have equals 12. Then I've got some like terms. I've got a 6x and a 10x, so those like terms can be combined. And that's going to be 16x. And we still have that minus 100 is equal to 12. And now we're down to a two-step equation. Opposite of minus 100 is 2 plus 100. And that's going to give me 16x equals 112. And we divide both sides by 16. And I'm going to get x equals 7. So now we have one answer. We have x equals 7. The second one's usually a little bit easier. So now we're going to take that x equals 7, and I can go into either of these equations. So I can go into this first one or the second one, whichever one is easier. I think the second one is easier. So that was the 2x plus y equals 20. And what I'm going to do is I'm going to replace that x with what x is equal to, and x equals 7. So now it becomes 2 times, instead of x, 2 times 7 plus y equals 20. 2 times 7 is 14. And then we minus 14 from both sides. And we get y equals 6. So then our complete answer is the ordered pair x is 7, y is 6. That's the point where those two lines would cross, or the only point where it works in both equations at the same time. The next couple examples we're going to look at are going to be more like this number 4, where we have some solving and replacing to do. For the last two problems we're going to do, solving by substitution really isn't ideal, but it is an option. So we're going to go over this so you can see how you could solve these with substitution. So we have to pick one letter to get all by itself. And I'm going to say that this x is probably the closest to being by itself. So I'm going to try to get that x by itself. So I'm going to minus 5y from both sides. That's going to leave me with negative x, that's gone, is equal to negative 13 minus 5y. And then with that minus sign there, that means there's really a hidden 1. So we're going to divide everything by negative 1. So now I get x, which is what we wanted, x by itself. And that's going to be positive 13 plus 5y. So now we have a value that we can substitute for. So I know that x is the same thing as 13 plus 5y. So then I can go up to my other equation, which would be this top one, and I'll replace x with this whole thing, 13 plus 5y. So that's going to look like this. We have the negative 4 out front, but then instead of times x, it's going to be times this whole thing. So we have to put it in parentheses to show that it's times that whole thing, 13 plus 5y. So that all replaces just that single x, and then everything else is going to stay the same. And then I'm going to do my distributive property. Negative 4 times 13 is negative 52. Negative 4 times 5y is negative 20y. Let me just bring the rest down. Then we've got some like terms here. Negative 20y and negative 15y can be combined. So that's going to be negative 35y. And then we're just solving the two-step equation. So I'm going to add 52 to both sides. It's going to give me negative 35. Y is equal to 35. And then we divide by negative 35 to get that y by itself. And then we get y equals negative 1. So all that work, and we finally have a single answer. We know that the y value is negative 1. So now, here's the easier part. Now we're going to go back up to either equation. We can pick, I'm going to pick the second one just because they're smaller numbers. So that's that negative x plus 5y equals negative 13. But what I'm going to do is I'm going to replace that y with the value we found, negative 1. So that's going to be negative x plus 5, but instead of 5 times y, it's now 5 times negative 1 equal to negative 13. And then I'm going to put that hidden 1 here so I see it. So it's a negative 1x minus 5. And we're going to add 5 to both sides. Negative 1x is equal to negative 8. And then we divide both sides by negative 1. And the x value then is positive 8. So our final answer, the x value is 8, the y value is negative 1. So that would be the ordered pair that works for both equations, or graphically where the two equations would intersect. For our last one, let's see, again, we're going to pick one letter to get by itself, whichever one is the easiest. And I think this bottom equation is going to be easier. And then even to avoid fractions, I'm going to choose to get that y by itself on the bottom. So I'm going to minus 4x from both sides. And this is not the only way. You could have choose to get any letter by itself and you're going to get a correct answer. I'm just choosing which one I think is the easiest. 2y is equal to negative 4x plus 26, or if you want to say 26 minus 4x, it doesn't make a difference. And then we're going to divide everything by 2. This is why I like this one, because I knew I wasn't going to get a fraction. And that's going to give me negative 2x plus 13. So now I know that y is the same thing as negative 2x plus 13. So I'm going to go up to the other equation, which is going to be that top one, because we haven't used that one yet. And I'm going to replace that y with this whole thing, negative 2x plus 13. So that's going to look like this. We have that 3x minus 2, and then instead of times y, times all this. We put it in parentheses, negative 2x plus 13. Then we still have that equal to 9. Then I'm going to do distributive property. That's going to give me a negative 2 times negative 2x is positive 4x. Negative 2 times 13 is negative 26. Then I've got some like terms I can combine here. So 3x plus 4x is 7x. And then we're just solving the two steps. So add 26 to both sides and get 7x is equal to 35. We're going to divide both sides by the 7. And then we get x is equal to 5. So then we have our first answer. We know that our x value is 5. So then I can go to my other equation, actually either equation at this point, and we're going to plug in x is 5. So let's see, I'm going to pick to use, I'll use the top one just because they're smaller numbers. So then we have 3 times, but instead of x, we now know that x is 5, so 3 times 5 minus 2y equals 9. That's going to be 15 minus 2y. Then we're going to minus 15 from both sides. We get negative 2y is equal to negative 6. Divide by our negative 2. And then our y value equals a positive 3. So there's our second part of our answer. So our final answer, the x value is 5. The y value is 3. And again, for these two, these are definitely not the easiest method for solving these. The method we're going to learn in the next lesson will be better suited for problems like numbers 5 and 6.